Hello, I'm Tun.
Hello, I'm Vivian. This is the setup we have. We have a mic connected to the mic deck and then connected to the laptop. Now let's take a look at the LabVIEW program. At first glance, you may notice that our program doesn't look like any traditional LabVIEW program. We have spent a lot of time and effort to make the UI more intuitive and appealing. It is also much more user-friendly. Let me first explain the various controls and indicators that are visible right now. We have the current time is shown in the middle, and the second show here, and we also have the PM and the AM indication here. Next is the day and the date indication, and we also have the alarm and the nap button. The indication are shown on the left hand side of the time. You can also choose the alarm tone at the bottom here. In order to help you select the music better, we have a preview button to listen to the alarm tone that you have selected, so that you know what you are getting into. We have a variety of tones for different people, like the normal alarm tone, like the bird melody, young people like popular songs. We have included two here. One is the Gangnam Style and another one is by Jay Chou. You can you can even select your own music from your library to wake you up. Let me demo the alarm function first. When you click the alarm button, there will be a dialog box asking you to set the alarm. After setting the alarm indicator will turn red as you can see here. There will also be an indication below the alarm button, which shows the alarm that we have set. When the alarm starts to ring, the UI will change significantly. You can see that the volume is increasing in the window media player. The buttons are also changed to stop and snooze. So now we will click the stop button first. Now we will demo the snooze function. First of all, you can key in the snooze interval you want by clicking the setting button here. The default is set to 10 minutes, but for demo purposes, we are going to set it to 0.1 minute, which is 6 seconds. So we will set the alarm now and show you how the snooze button works. Now we will click the snooze button. You will notice that the alarm indicator remains red and it will ring again after 6 seconds. We have included a special nap button to let you rest for a short period of time. This is what we call a shortcut button because you only need to click it once and you are all set. The alarm will wake you up in a short while. The default nap time is set to 25 minutes because this shirt has shown that 20 to 30 minutes nap is very helpful for our health. Of course, you can change the nap time to any interval that you like. You can go setting button and change there. For our demo, we will use 0.1 minute again, which is 6 seconds. And you can see that the nap indicator is lit up. And now we will stop it. When the alarm is activated, we have a graph showing the mic input. If you clap, you can see if the waveform will change. The number on top indicates how many claps you have done. The dial below shows that you have 5 seconds in between each clap. The dial indicates how many seconds you have left. When the dial reaches 0, the count will be set to 0. And when the count reaches 3, the alarm will stop. We also implement a switch to off the light so that you can sleep better with the dimmer light. You do not have to manually reduce the brightness of the monitor. The color of the time will be switched to white so that you can see better. Other functions will remain the same with the light off. The other thing that we have done is that we loop the window media player so that when the alarm tones and it will repeat again. The alarm will go on and on until the stop button or the snooze button is pressed. Lastly, we also had a stop button to end the program.
Let me continue with our block diagram to see the actual implementations. First off, this flat sequence is used to initialize some of the various states. We have reset some of the indicator status to 0. Need to set some of the switches to false, and to hide the custom song selection. At the same time, we also need to input a picture for a background. We need to reset some of the timestamps. Need to hide some of the indicators here, and we have set the default snooze time to 10 minutes and 25 minutes to the nap time. We also need to show the preview button and hide the pause button. This block here is how we calculate and show the current time. We use the time function to get the current time from the system, and then we format it into different arrays to indicate that, to get a visual look that we want. So we separate it into second string, AM, PM string, date and day stream, and hour, minute stream. We also use the data to compare with the alarm time that we set or the nap time that we have set. If the alarm time if the difference is more than 0, which means that we have set the alarm, we're going to show the alarm indicator. I'm going to set the status. At the same time, if you have set the nap time, you're going to show the nap indicator and set the status. Anytime when the difference of the alarm time or nap time and the current time is less than 0.1, which means it's like the difference less than 1 second, I'm going to activate the alarm. This block here shows how we shows the different alarm tones. Now, instead of using a constant string path for the music, we get this VI to get a current path in the project, and we then use a folder inside the current project. So everyone who has the whole project can play this music. It's no longer dependent to my computer here. And then the music path is then input into the Windows Media Player. So when the user is selecting any of the built-in ringtones, the custom song selection will be made invisible to the user. Only if he selects the custom song, then he will be able to see the control to select his own music. We have an event structure here. I'd like to mention that our program is mainly based on the state machine. These numbers here shows the different stages that we are in. For example, when the stop button is pressed, we will switch the alarm activated to false. We switch off the alarm, and we will set the different states for different indicators. The same goes for the clap button. Clap button means when the user clap 3 times, we're going to stop the alarm. And we have a snooze button. Snooze button here we have two indicators to get a hold of which one is active. For example, whether the alarm or the nap is active during when we press the snooze button. And we also have a set nap, so we need to set the nap time and set alarm time. Here I will show how the Windows Media Player works. So for the first state, we're going to initiate the Windows Media Player with different controls. We're going to input the path. We're going to set the volume to 0, the current position to 0. We're going to loop. We're going to make the loop to true. And this is a flat sequence. We're going to execute after this. We're going to move to the next state. In the next state, we're going to increase the volume by making use of the timestamp. In the sense, it's a timer. We're going to increase every 500 milliseconds. 500 milliseconds, we're going to increase by 5. And when it's done, we're going to move to the next idle state. And when the user press the stop button, we're gonna stop the Windows Media Player and reset it to 0. This block here shows how we recognize the clap. This DAQ assistant is connected to the audio mic input. The data we get, we're going to show it on a graph here, and we're also going to go through a waveform. This gives us the amplitude of the analog input. We then compare it with a threshold, and if it's more than that, we're going to say that we recognize a clap. And then we are going to go into a state machine for the clap. So we're going to move to the next state, and we're going to set the time. So when the time is less, we have set a threshold to 5 seconds. So within 5 seconds, the user have to clap again. If not, we're going to reset back to 0. When the user clap more than 3 times, or 3 times or more than 3 times, we're going to reset to 0, and we're going to activate the event structure.